Welcome to this video and thank you for tuning in. The subject matter of this presentation is on acid-base disorders. And my aim here is not to give you a formal lecture on acid-base disorders. The goal is to give you a simple tool that will enable you to tackle questions on this subject matter. This is one of those areas that are often neglected in clinical chemistry, and so I like to classify them as outliers. That's my favorite. And so we'll be in the exam mode right away, and then we'll go straight to the subject matter. I want you to take a look at this. Now you go into the exam hall, ready, and then you click on the computer screen, and then the first question you see is one that is attempting to find out your ability to distinguish one of these disorders from the other. Here are the four primary acid-base disorders, and they can be very confusing. What this presentation will do is to enable you confidently and successfully sort one from the other, depending on what the question is. So, here is the tool. This is the tool I have for you. Your ability to reproduce this tool in an exam hall will go a long way to bolstering your confidence, so that you come in and then you turn into exam question 1 or number 40, and then you see a question on acid-base disorders. Then you reproduce this table, and then we are going to walk through and show you how you can do this very easily. It may look daunting at first glance, but I assure you this table is very, very effective, and you need to practice it. You need some time, and you need to put in some effort. Now take a look at this table. You see I have this arrow going down here, and then the other arrow is going in the opposite direction. So down here, up here. On this side of the table, you find this arrow going up and this one going down in the opposite direction. That is the beauty of this table. And in each of these, I call them quadrants: first quadrant, second quadrant, third, fourth quadrant. In the first quadrant here, you find the same, the ratio bicarbonate and the partial pressure of carbon dioxide. That is repeated in each of these. And then what this says here, how to interpret this table, is that when you have this table here, this arrow pointing down here, it shows a decrease in bicarbonate, and this is the condition that amounts to metabolic acidosis. Over here, you find this arrow going up here, an increase in the partial pressure of carbon dioxide. Here is a case of respiratory acidosis. Over here you have a case of metabolic alkalosis, and the arrow is increasing in this direction in the bicarbonate ion. And then finally you have this arrow looking downwards here, and here is a case of respiratory alkalosis. Okay, so the next step is to see how we can reproduce this table. The first thing you do is to draw you a cross. Get a pen and paper ready, and then see if you can follow me at the same time. And then you have your cross like this, okay? Let's extend it further down here and up here, so you have some room. What you do here in this first quadrant is to write this here, the bicarbonate and the partial pressure of carbon dioxide. And so you reproduce the same ratio over here and in all 4 quadrants. Okay? Now, the next thing to do, I'll use the red pen just for clarity. You put this arrow downwards here. So you say down, and then in this other quadrant opposite it, you have this up here. All right? So over here, you say up here in the opposite direction to this other arrow, and over here this one will be in the opposite direction to this. So here we go. This one is down here, and then this one is up here. In these 2 quadrants, we are dealing with the PCO2. Okay? Over here, we are dealing with the bicarbonate. Now, when you have done that, you're almost halfway through. What you need to do is to remind yourself that this upper half of this figure refers to acidosis, cases of acidosis. And this lower portion here will be alkalosis. All right? Now there's still one more thing to do, and that is the pH. You remind yourself here that when you have a pH that is less than 3.5, no, 7.35, I'm sorry, 7.35, it amounts to a case of acidosis. On the other hand, if you have a pH of greater than 7.45, you will be looking at a case of alkalosis. So that's that table. It's not complicated. But one final thing you need to do is to remind yourself that on this half here, because you have the PCO2 and the PCO2 here, you put respiratory. Here, respiratory. Okay? Over here, let's just call it metabolic. Everything on this side is metabolic. All right? So, here is how to interpret the table. A case of metabolic acidosis is one in which you have a decrease in the bicarbonate. A case of respiratory acidosis is a case where you have an increase in the partial pressure of carbon dioxide. A case of metabolic alkalosis is a situation in which you have an increase in bicarbonate and then the pH is greater than 7.45. In this lower half here, we refer to alkalosis, and we expect the pH to be greater than 7.45. So this is how to reproduce this table, and once you have this table, you can answer all manner of questions. Now there's one more thing you need to know, and that is that there is some bit of memorization that needs to go along with it. And it's not a whole lot of memorization. I don't like memorization, but there are times you may have to, and in this exam there will be lots and lots of areas to memorize. That's why your ability to produce this table in quick time will minimize all the congestion you have in your brain trying to memorize a whole lot of data. These are the only three you need to memorize. The pH, which has a range of 7.35 to 7.45. The partial pressure of carbon dioxide, which has a range of 35 to 45 millimeters of mercury. And then the bicarbonate ion, which ranges from 22 to 26. You don't need to be concerned with total carbon dioxide or partial carbon dioxide or sodium or calcium or any of the other ions that a standard blood analyzer will be able to generate. Now, these are the arterial blood gas reference ranges, and these three are the ones that you should be most concerned with. And the reason is simple, because in the table we drew a little earlier on, we had three major players here, or variables. We had the bicarbonate ion, and then we had the partial pressure of carbon dioxide. So, you need to know the reference range for the pH. You need to memorize the reference range of the bicarbonate, and you need to memorize the reference range of the partial carbon dioxide. And I said earlier, this one is 7.35 to 7.45. Okay? And then the bicarbonate is from 22 to 26. And then the partial pressure of carbon dioxide is from 35 to 45. Okay? The beauty about this is that you see 35 here, see 35 here, 35 here. So somehow you begin to remind yourself that there's, okay, this one is a P, this one is a P. So they have, once you retain this in your memory, when you write this one down, you know this has a P, this has a P. This is how I memorize it. The 35 that is from here will remind you that this is the range you're looking for. This is the only one that's a little odd out. But these three you have to memorize, because without that you cannot successfully interpret the questions. And we'll be looking at how this could be utilized in an exam situation. In the table I showed to you earlier, you would see metabolic, respiratory. Now, one way to make sense out of this bundle of confusion is to take a look at this ratio here. The numerator here, the bicarbonate ion, refers to the metabolic process. So when you hear the word metabolic, your focus should be on what is going on here. Is this increasing or decreasing? And the denominator here refers to the respiratory component, say respiratory acidosis or respiratory alkalosis. Your focus should be here. What is going on here? Is this increasing or decreasing? And what amounts to acidosis or alkalosis will depend on whether this is rising or, decreasing. And that means you ought to memorize the three ranges for each of these. Okay? Now let's see how we can use this, or how we can approach a question in an exam. Let's take a look at this question. It says, a patient's blood gas results are as follows. The pH is 7.27. The partial pressure of carbon dioxide is 62 millimeters of mercury. The bicarbonate ion is 28 millimoles per liter. And the total carbon dioxide is 26 millimoles per liter. Which result best describes this patient's acid-base status? A, is it a case of metabolic acidosis? B, is it a case of respiratory alkalosis? C, is it a case of metabolic alkalosis? Or D, is it a case of respiratory acidosis? So you have a choice. The choice is to make a guess, and you don't want to do that. The other choice is to attempt the question with the confidence that you bring to the table. And that confidence is based on your ability to reproduce that table if everything else fails. So here we go. Let's try to attempt this question. What you need to do is to, put up this ratio here, bicarbonate ion, and then the partial pressure of carbon dioxide. Okay? Now, the information we have says that the bicarbonate ion is 28 millimoles. Just put 28 there. And then the partial pressure of carbon dioxide is 62. Just put 62 there. And that the pH is 7.27. 7.27. Here we go. Those are the pieces of information you need. This one here, I just put it for to confuse the total carbon dioxide. You don't need this information, but I put it there on purpose, so that if you know what you need to know, you know what to shop for. It's like going into a shop and picking what you need, and what you don't need, you ignore it. You don't need total carbon dioxide for this computation. All right. Once you've done that, then the whole idea of the range thing I talked about earlier will come in. The pH range, should be from 7.35 to 7.45. And then for the bicarbonate ion, we said is from 22 to 26. Okay? And then for the partial pressure of carbon dioxide, we said it's from 35 to 45. All right? So here we go. What is happening here is that 28 is well beyond this, not a whole lot. So you put an arrow here, a little teeny arrow. Here you have 62 is outside this reference range, over here. So here is a much bigger arrow. Okay? The pH, on the other hand, is 7.27. It is lower than this. So you put a drop. It's a case of right away acidosis. All right? So the question then remains, what is the primary disturbance? What is responsible for the disorder? Obviously, it is this major increase here in the partial pressure of carbon dioxide. So this is a case of respiratory acidosis. See, that makes it simple. So you come back here and your choice will be respiratory acidosis, D, and then you move on. The exam is 100 questions, and then you have 2.5 hours, and then if you do the maths, it boils down to 1.5 minutes per question. You don't have too much time to spend on this, but once you have your table, you reproduce it. It tells you what you need to know, that when the arrow is here going up and the pH is acidic, it's a case of respiratory acidosis. All right? I hope this helps, and then there will be more extension of this discussion in a later part of the video. Thank you very much, and good luck as you prepare for your exam.